All right, we are going to review radical rules here. Now, my hope is that you were able to be in class with me and you already heard these in person, because I think this is one of those lessons, especially that it's easier to learn when you're in person than when you're trying to watch a video. But in case you were absent, or in case you just want to go back over the rules, here's the video that you can watch and you can hear how to work with these radicals. Now, let me do a quick side note here before we do this. When I talk radicals here, I often mean this radical sign right here, which is implied that it is the squared root. That means that I am looking for pairs of factors that come in groups of 2. So one really quick, easy way to look at something like this is if I say something like, I have 2 2's, or 2 squared, times 3 squared, and maybe times x squared, okay? So when I have this invisible 2 out here, like it looks like right there, or if the 2 is there, it's saying you can pull something out of this radical if it's in a group of 2. Well, this 2 is a group of 2, so I can pull it out. This 3 is a group of 2, so I can pull it out. This x is a group of 2, so I can pull one of them out. As long as there's a group of 2, you pull out what group of 2 that is. And this answer would be 6x for the square root of all of this stuff, okay? So just a note, if you see a radical and it has a little 3 in there, it's saying the cubed root, or it's saying I want to find how many groups of 3 there are, okay? And I'm going to take a big step here, and I'm going to show you this one, and I'm going to say the cubed root of 27y to the 6th, okay? So it says it's looking for groups of 3. Well, that means 27 is really 3 times 3 times 3, okay? And, of course, y to the 6th. I'm going to change it to y and a 3 and a y and a 3, because that's still 6 y's. I just split it up. So when you think about this, if I ask you what's the cubed root here, the cubed root means I need 3 in a group. Well, there's a group of 3 3's, so I can pull one out. There's one group of y's there. There's one group of y's there. So that means I pulled out 2 groups of y's. And then I get 3y to the 2nd. So those tiny numbers up top tell me how many I need to have in a group, okay? Now, I'm going to tell you in geometry, we pretty much only work in the square roots. So what I talk about today applies to all radicals, but specifically what I talk about is going to be square roots, because that's what we're going to use the most, and we see the most in geometry. So just a quick note when you look up at the top, I put some square roots at the top of the page, I put some square roots at the bottom of the page, but the square root of 4 is 2, because if you know that 2 times 2 is 4, okay? So 2 times 2 is 4, so the square root of 4 is 2. 3 times 3 is 9, okay, and that's where you get the square root of 9 is 3. 4 times 4 is 16, you get the square root of 16 is 4. Okay, so all of these are squares. You've seen these before, you know what it is. Now, just for my sake, and for how I like to teach this lesson, I call these numbers pretty numbers. These perfect square roots, the 4, the 9, the 16, the 25, I call these numbers perfect square roots, okay? Because they're perfect square roots, and then I like to call them pretty, because they're pretty numbers. If I see a pretty number inside, I can pull a factor outside, okay? I'll also call numbers that aren't perfect squares, I'll call them uglies, because the uglies have to stay in the house because they're not a perfect square, okay? So just kind of a heads up as we go through this. Okay, so our first example, one thing I want you to know is a square root sign works like a parentheses. And if you remember my dear Aunt Sally, she always says, please excuse my dear Aunt Sally, parentheses first, then you can do exponents, square roots, whatever we need to do, okay? So we want to get everything inside of a square root down to one number before we take the square root. So we'll start with an easy one on example A. I have 40 plus 9. Well, 40 plus 9 is 49, so I join those together. Now I take the square root. Do I know the square root of 49? What number times itself is 49? Well, it's on my list up here. It's 7. But I do want to warn you, the answer technically is positive 7 and minus 7. So there's my answer. In geometry, almost everything we do is dealing with positive numbers because we deal with lengths of things. And you can't have the length of your rectangle be negative 7. So because of this, I will allow you to just tell me the answer is 7, But in the back of your mind, you need to remember there's technically two answers, because when you get into algebra, you're going to have to bring back those negative answers as well. But for right now, we can do just the positives, okay? Example B, I have the square root of -6 squared plus 8 squared. So right now, this square root is kind of a big set of parentheses, okay? So we've got to get what's inside down to one number before we take the square root. So inside these parentheses, I see exponents. I have to do that before I can add. So -6 squared, that's saying -6 times -6. Well, that gives me 36. 8 squared, well, 8 times 8 is 64, so I get 64. All right, all of that is still inside my radical. So now I need to do some addition. 36 plus 64, 100, and the square root of 100, again, we're going to stick with the positive one, is 10. Okay, looks pretty. Here's the thing. Do you think all of the answers we get are always going to be perfect squares? Well, if you said no, you'd be correct. Because all the numbers we work in math, not all of them are perfect squares. In fact, when you look at the list, I mean, you can get to big numbers pretty quickly, and there's a lot of numbers in between them that aren't perfect squares. So our rule in geometry, if I say I need a simplified radical, means we're going to factor out and bring out as much outside of the radical as we can, but we're going to leave anything that doesn't come out as a nice factor inside the radical, okay? And this is where my radical world comes in, okay? I'm going to ask you often, is there a pretty factor in my number? If there is, we're going to break it down using that pretty factor, and the pretties are allowed to come out in the yard, and the uglies have to stay in the house where their neighbors can't see them. Okay, so here's my first one, square root of 99. 99, if you look at your list of perfect square roots, it is not on that list. But is there a factor on my pretty list that does evenly divide into 99? So we're going through our list, 4, 9, 16, 25, 36, 49, 64, 81, 100. Guys, quick hint. You can't have something divide in that's bigger than the number itself, so 100 doesn't work. In fact, the best you can do is half of it, 2 into 99. Well, that's a decimal, that doesn't work. But it's got to be smaller than 99. So how about 9 times 11? Notice I didn't change the value inside that square root, I just broke it apart. I call it my breakdown. You'll hear me say that, breakdown. So I find this, and I choose this because 9 is on my pretty list. It's a perfect square. So now I can break this into 2 square roots, the square root of 9 times the square root of 11. Well, the reason I chose this is the square root of 9. Is that pretty? Definitely. So he gets to turn into 3, and because he can turn into 3 because he's pretty, he can be outside in the yard. Square root of 11, he is not pretty. He has to stay in the house so the neighbors can't see him. Does he have any factors in the pretty list? Hint, hint, 11 is prime. He has no factors but 11 and 1. He does not get to become pretty. We are all done. We pulled out the pretty out of the house, and we left the ugly inside the house. There is my simplified square root, my simplified radical. By the way, you're going to hear me call radical and square root back and forth. A square root is one type of radical, but you'll hear me say that a lot. All right, so we have the next one, square root of 48. It is not on my pretty list. It's so close, 49, but nope, not 48. So does 48 have a factor that's on my pretty list? Oh, I see 4. 4 goes into 48, okay. So I'm going to break this down to 4 times 12. 4 times 12 is the same thing as 48. So now I can do a split, right? Square root of 4 times the square root of 12. Square root of 4 is 2. It's out in that yard. It's beautiful out there. But 12 is not pretty, so it has to stay in the house. Okay, but I always stop and say, wait, does 12 have a factor that is also on my pretty list? So again, I check. Well, there's only 2 numbers smaller than 12, 9 and 4. Do either of those divide equally into 12? And the answer is yes. I could turn 12 into 4 times 3. Okay, so this is where we have to be careful now. So I have this 2 outside. I have a square root of 4, and I have the square root of 3 when I split this apart. The square root of 4 is 2, and there's already a 2 outside. If there is a number outside the radical already, you have to multiply the two numbers together. So 2 times 2 is 4, so we get 4 square root of 3. These multiply together, okay? Now, I know somebody's watching this and saying, oh my goodness, why did she make that so hard? Let me do this problem one more time, okay? Square root of 48. Is there a pretty that goes into it? And somebody tells me, oh, 16. 16 goes into 48, right? We could turn 48 into 16 times 3. Well, what's the square root of 16? 4. So I bring 4 outside, I'm 3. I'm done. I got the same answer though. Here's the thing. Some of you will see a big factor. Some of you will only see a smaller factor. You can do it both ways. One has more steps, but maybe it's a number that you are more familiar with. One can grab bigger factors and get the job done faster. Either way is fine. So just make sure you show your work so I know which way you've chosen to do it. Okay, example E here. There's already a number outside in the yard before I start here. And I have 300 in the inside. Well, my list here doesn't even go to 300, but you have to think, is 300 a perfect square? Is there a number times itself that equals 300? I don't think there is. Is there a factor of 300? I think 300 can split into 100 times 3. So this is the same as 300, 100 times 3. I didn't change its value, but I can split it into two separate square roots. What's the square root of 100? 10. What's the square root of 3? Not pretty. We leave it inside. Remember, this 2 was already out there. What happens with the 2 and the 10? They multiply. So on the outside, I get 20 square root of 3. Does the square root of 3 have any more pretty in it? No, not at all. So we're good right here with 20 square root of 3. Okay, so that's simplifying or breaking down a square root. Now, you have to think there's all kinds of numbers, so sometimes you have to play with them. When the numbers get really big, I often tell people divide by 2 or 3 and see if the other factor is a pretty number. So the sooner you can pull out a big number that's a factor, the quicker it is to reduce that, okay? All right, adding or subtracting radicals, okay? Don't have a lot of room on my screen here, so we're gonna have to hope that we can do this kind of small. Okay, did I tell you the radical world is a mean world, okay? There's this rule in the radical world that you can only play or hang out with your neighbors if you have the same ugly, okay? So if you can't figure out if you and your neighbor have the same ugly, then you're not allowed to play together. And that's what I call this adding and subtracting of radicals. The first thing we have to do every time is we have to simplify the radicals, okay? Because right now the square root of 175 minus the square root of 28, they are not allowed to play together because they don't have the same ugly. So I look at the square root of 175 and I say, is there any pretty I can pull out of the square root of 175? Well, it ends in 75. I'm thinking, I can make quarters with that. And 25 is one of my factors. So let's see, 25 times, what is there, 7 quarters in $1.25, 75? 25 times 7. Okay, what's the square root of 25? 5. What's the square root of 7? 7. Did you notice I kind of skipped a step there? If you can do that mentally, you're allowed to skip that, okay? The perfect square comes out front, the radical stays inside. 28, 4 times 7, okay. Square root of 4, 2. Square root of 7, not pretty, stays inside, okay. And then I bring down this negative that was in the problem to start with. So the first thing I do is, when I add or subtract, is I simplify all my radicals first. So notice I have 5 square root of 7 minus 2 square root of 7. Now that I notice that my two neighbors have the same ugly, the square root of 7, I am allowed to add or subtract them together, okay? So if they have the same number under the radical, you can add or subtract the numbers in front of the radical, but we leave the radical alone, okay? If you think about this, what if I had 5x minus 2x? From algebra, we know that if we had that, we would just subtract 5 minus 2 and we get 3x. Did we touch the x? No, it's just like a label, like a last name, right? Or an ugly, right? So I have 5 square root of 7 minus 2 square root of 7. They have the same ugly or the same last name, so I'm allowed to join the first one. They can play together there. 5 minus 2, well, that's going to be 3, and then I just leave the square root of 7. Okay, I have to leave it because it's its value, it's its last name, or whatever you want to call it, but I don't do anything with it now. So my answer is 3 square root of 7. All right, example G here. I have 3 radicals. Currently, nobody's allowed to go out and play together. Nobody has the same ugly. So we have to check and break it down first to see if there are any neighbors that are allowed to get together. So the square root of 32. Well, let's see. I could make that 16 times 2. Square root of 75, I'm thinking those quarters again. 25 times 3. And 162, that's getting big. Think about dividing by like 2 or 3 and see if it divides. Well, 162 divided by 2, 81. That'll work. I like the big numbers there. Okay. Time to go through and simplify. 16 square root of 2, or 16 times 2. The square root of 16 is 4. It comes out in the yard. It's allowed to be seen. Square root of 2 has to stay inside where the uglies stay. All right, on the next one, square root of 25 is 5, but 3 is ugly, so he stays inside the radical. And finally, the last one, the square root of 81 is 9. That comes out front, and the square root of 2 stays inside where it's ugly. All right, we've simplified these. Now the question is there any of the same uglies? Can anybody in the neighborhood play together? And we look and say, wait, I see a square root of 2 over here with the 4. I see a square root of 2 with the 9. Those two are allowed to play together. And remember, we only join the outside numbers, and we look at the sign given in the problem. So I have 4 square root of 2 plus 9 square root of 2. 4 plus 9 is 13 square root of 2. And those two can join together. And then that 5 square root of 3, that poor neighbor, he just has to watch. He's not allowed to play together. They're not allowed to be together. So he just stands outside and watches, but you got to add him on there, plus 5 square root of 3, okay? You can't just drop the neighbor from the neighborhood. He's still living there, okay? So if they have the same ones, you join them together. If they don't, you just leave a plus or minus sign between them, and you don't let them get together, okay? It's just this cruel, cruel world in that radical world, okay? Questions on the first part of our radical rules? All right, let's move to the back page, okay? And we're going to go, let's see, we've added them and subtracted them. So now we're going to go ahead and multiply them, okay? So the radical world, it is pretty mean, pretty radical at times, but it gets better when it's time to multiply, to get married, to, it's time to see what can we do. When we multiply radicals, we're allowed to join anybody. Anybody, no matter what their pretties and uglies are, they are allowed to get together, okay? The rule is make sure you multiply all the numbers outside together, and then make sure you multiply all the insides together. No outsides without insides and no insides with outsides. And then if possible, we simplify the radical. But we don't even care what they start with. You're allowed to multiply everything together. So on H, I have an invisible 1 out front, an invisible 1 out front. So when I do those 1 times 1s, I still get 1. Then I go square root of 8 times square root of 10, and I get the square root of 80, because I'm allowed to multiply anything and everything together. All right, that 1 out front's really not doing anything. But I look at the square root of 80 and I say, wait, does it have any pretty? Because I can't finish until I know that I pulled all the pretty out in the yard I can. Square root of 80. Well, 4 goes in, right? 4 times 20. Square root of 4 is 2. Square root of 20 is ugly. But does 20 have any more pretty? Well, let's see. 4 goes into 20 again, so I can break that apart again. Okay, 4 times 5. And this time, this square root of 4 is 2, and it's going to multiply by the 2 out there, and I'm going to leave the square root of 5, and I get 4 square root of 5. Okay? Some of you may have said, wait a minute, square root of 80, that's the same thing as 16 times 5. And guess what? That would have made 4 square root of 5 as well. Remember, it's okay to do it in small steps. It's okay to do it in a giant leap. Do what's comfortable for you as long as we get the same answer. All right, let's try example I. We're multiplying, and anything can multiply together. In this cruel, cruel, radical world, you can multiply with anybody. You can make all kinds of kids, and sometimes you create some new pretty. So Outsides, 4 times 2 is 8. And then we're going to do the square root of 6 times the square root of 15, which is the square root of 90. All right, so when we multiply the outsides, we get 8. When we multiply the insides, we get 90. 6 and 15 did not have any pretty in them. But suddenly, when they get married and multiply, they created some pretty. What kind of pretty is still existing in 90? Well, it looks like it has a factor of 9 times 10. We can't forget they already had some out in the yard. Square root of 9 is 3. Join that to the 8 that was out in the yard, and that always gets multiplied. And we leave the square root of 10 inside because it is ugly. 8 times 3 is 24, and the square root of 10. Does the square root of 10 have any more pretty? Well, the only numbers smaller than 10 on my pretty list are 4 and 9, and neither of those go in equally, so I think we're done right there, 24 square root of 10. So multiplying radicals is probably one of the easiest because you don't have to worry about too many people not being able to get together or anything like that. Everybody gets together. Just look for the new pretty they create and bring that out. All right, dividing radicals. We multiplied, we added, we subtracted. Now it's time to divide. But the one thing I want you to realize is we don't technically divide by radicals. The rule is one, it's called rationalizing, but the rule is you are never, ever, ever allowed to have any radicals / monsters in your basement. Okay, it's a scary place. You're not allowed to do that. It's illegal to leave a monster in your basement. You got to get it out of there. You're allowed to have that monster on the first floor with you. Upstairs where people might peek in the windows and see you're ugly, but no way can you hide that thing in your basement, okay? So make sure that you do not leave a radical in the denominator, okay? So there's multiple things we can do. One thing I need to make sure you know is that, of course, when we talk about radicals or dividing, it really is a fraction, okay? So you can have the square root of 9 on top of the square root of 16, something like that, right? And you can treat them separately. You can say, oh, I know the square root of 9 is 3 and the square root of 16 is 4, okay? That's one thing you can do. You could have the square root of 5 over the square root of 20, okay? And right now I look at that and I'm like, those are not pretty. Well, here's the deal. If they're under together, and I should have written it like this. Let me fix just a little bit, okay? So you understand this. If you see the square root of 5 or the square root of 20 like this, I can't take the square root of 5. I can't take the square root of 20. But I am allowed to make it one big square root, okay, and reduce my fraction. Well, if I reduce 5 over 20, it becomes 1/4. Well, that's not bad. The square root of 1 is 1. The square root of 4 is 2. That makes it a lot prettier, right? So you're allowed to leave things separately, or you can join them in one and reduce them, whatever one works better, okay? So when I go to example J here to start with, we always want to turn all of these into a fraction, and that one's already a fraction. And I look at square root of 192, and I look at square root of 3, and I don't like it. I don't know those numbers. They're not pretty. But if I put them on top of each other, does it reduce? 3 goes into 19, 6 times 18, and 12, 4 times. Oh, I get the square root of 64. That's nice. It becomes 8. Okay, that worked out nice because I can take two radicals, one on my first floor and one in my basement. I can combine them and reduce them, and then all of a sudden I don't have a basement left anymore. So I got that radical out of there. Okay, second one here. 6 divided by the square root of 2. I know it seems really silly because we're like, why would we ever create fractions? But I can't stress enough to you how this is the best way to handle a dividing by a radical. So I'm going to do 6 divided by the square root of 2. Okay? Now, my top floor does not have a radical in it, but my basement does. So I can't do what I did in my last example where I joined them up because you can't join an outside number with an inside number. But I don't want a radical or a monster hiding in my basement. Okay, so the best way to get rid of that is to multiply by 1. Well, if I do that, I just get 6 over the square root of 2. That doesn't look very good. But I'm going to change the form of 1. 1 is a number. Can I write 1 in a different way? I can. And this is going to seem a little bit silly, but follow me on this. the square root of 2, if I can multiply it by the square root of 2, I'm going to get a nice number. But I need to multiply by 1. If I want this value to be 1, I need to have the same thing on the denominator as I do on the numerator, and now that has a value of 1. I chose that value of 1, but I made it there. Okay, I can multiply by that because it really equals 1. So I multiply across the numerator. 6 times radical 2, 1's an outside number, 1's an inside number. It stays 6 to the square root of 2. In the denominator, the square root of 2 times the square root of 2 becomes the square root of 4 because I'm allowed to multiply numbers inside radicals together. Well, the square root of 4 is 2. I like that. That's what I was hoping to get. Remember, I chose that number so I could get a number outside that was a whole number. And now I have one more step. Reduce if you can. And remember, just like when we multiply and outside numbers multiply together and inside numbers multiply together, when we reduce, outside numbers reduce together and inside numbers reduce together. So I can only look at this 6 and 2 together because they're my outside numbers. What is 6 divided by 2? 3. And then I leave my radical 2. And there's my simplified answer. It looks a little different than what I started with here, right? And the main thing is there's no more monsters in my basement. There's no radical in the denominator. It's fine if my answer has a radical as long as it's not in the denominator. Okay, so let's try this process one more time. I'm going to change the color so it doesn't blend with all the rest of my ink. Right now they have it set up as a fraction, 2 over the square root of 5. I can't join them right now. One's an outside number, one's an inside number. I can't have that radical 5, that monster in the basement, so I got to get it out of the basement. How do I get it out of the basement? I multiply by itself. But if I multiply a denominator by the square root of 5, I have to do the exact same thing to the numerator so that it's multiplying by 1, and I multiply the numerator by the square root of 5. Across the top, 2 times the square root of 5, an outside number and an inside number simply hook together, 2 square root of 5. In the denominator, square root of 5 times the square root of 5 is the square root of 25. Well, the square root of 25 is 5, that's a perfect square, and on top I still have 2 square root of 5. Do my outside numbers simplify, that 2 and that 5? No. And I'm not allowed to simplify an outside number and an inside number, so I can't use those 5s together. I am done right there. Does that answer look super pretty? Maybe not, but it follows the rule that I have no radical in the denominator, or I have no monsters in my basement. It's okay to have them on the first floor, but never in the basement, okay? So when somebody says, how do you divide a radical? You really don't divide. You change the form so that you don't have it in the division problem, in the divisor anyways. All right, last set of notes here on my radicals is squaring a square root, okay? So let's talk about opposites. In math, if you add something to something, you go and undo it with subtraction. If you multiply by something, if you want to undo it, you divide. If you square something to undo it, you take the square root. They undo each other. They're opposites of each other, okay? So a square root and a square cancel each other out, okay? So I could do this problem right here. I could have the square, it says the square root of 24 squared. So that would mean the square root of 24 times the square root of 24, okay? Do I have any great people on there that can multiply for me right now? 24 times 24. Because remember, I can multiply square roots together. So I can multiply those numbers together. So what is 24 times 24? Okay, and you said it was 576. Okay, so now we get the square root of 576. So then I'd ask you, okay, what's the square root of 576? Well, I can tell you it's probably not on my paper, but if you plug it into a calculator, the square root of 576 is 24. So there's my answer. All right, that was a lot of work with a lot of big numbers. If you remember that the square root cancels the square, when you see the square root and the square, you can cancel and say my answer is 24. You don't have to go through all those big numbers, okay? So I like this rule. They cancel each other. They're gone, and it leaves you with the number and the radical, okay? But I want you to be careful on example N, because when you square something that has something outside, everything gets squared. So the 3 gets squared, and the square root of 6 gets squared, okay? Now, the 3 squared doesn't cancel anything. You need to square it. What's 3 squared? 9. Square root of 6 squared, though, the square root and the square cancel each other, and I'm left with 6. Now, what do you think we should do with that 9 and 6 together? We should probably multiply it. 9 times 6, that'll give us 54. So there's my answer when I square that, okay? When you square a square root, you should get a whole number every time. If there's a number outside of it, make sure you square that as well and multiply the two together. And that's our radical rules. For some of you, this may have been the very first time you've ever gone through them. For some of you, you did get a lesson. And we're going to spend a couple days practicing it, okay? So we're going to work on a worksheet to practice. We'll answer some questions again when we're back together again and check it again. Because this is something we're going to use a lot in geometry, simplifying a radical. I remember there's a lot of tests that we have radicals on it, and I want you to be able to use them, and I want you to be proficient in these radicals. And basically in geometry, we're going to use square roots. That's our most common radical, although there are such things as cubed roots, fourth roots, fifth roots, and so on. All right. Good luck on the homework, and please bring me questions if you're struggling on any of it.